So again, in order for us to solve this problem, what we're going to need is the augmented matrix of the system, which is 1, 2, 1, 2, 5, 0, 3, 3, 8, B1, B2, B3. Okay, so the first one will play the role, this one here will play the role of the leading coefficients, and what we want to do is to get rid of this one and this one by using row elementary operations. So we get, so first we take R2 minus 2R1 and R3 minus R1. So we keep, of course, the first row, 2 and 3, B1. So 2 minus 2 is 0, 5 minus 4, 1, and 3 minus 6 minus 3, B2, minus 2, B1. And the bottom is 1 minus 1, 0, minus 2, 8 minus 3, 5, B3, minus B1. Okay, next we use now these leading coefficients, and we want to remove this one here by using the elementary operations. So for that, we are going to take R3 plus 2 R2, the second row. So this will give me what? So we keep the first 1, 2, and 3, B1, 0, 1, minus 3, B2, minus 2, B1. And finally, we get 0, minus 2 plus 2, 0, 5 minus 6, minus 1. And then we get B3 minus B1 plus 2 times B2 minus 2B1, which is B2 minus 4B1 now. Okay. Or we can do some algebra here. 1, 2, 3, 0, 1, minus 3, 0, 0, minus 1, B1, B2 minus 2B1. One has to be extremely careful about the algebra. B3 minus 5B1 plus 2B2. I mean, we can put them in an order, minus 5B1 plus 2B2 plus B3. Okay, so now let us multiply by minus for R3 to have a leading coefficient equal to 1. So we get 1, 2, 3, 0, 1, minus 3, 0, 0, 1. Okay, so we have B1, B2 minus 2B1, and let us put it in a nice order, which is 5B1 minus 2B2 minus B3, because I multiplied by minus. Okay, so now we got the echelon form. This is the row echelon form. What is the rank of the matrix? R is equal to 3, and therefore we have 3 unknowns, 3 equations, and no 0 rows in the coefficient matrix side, okay? Which means that this matrix is invertible. The system has only one solution, okay? So the system here, we can see this, has one solution, independent of what? B1, B2, B3, which means that this is the same as saying that the coefficient matrix equal to 1, 2, 1, 2, 5, 0, 3, 3, 8 is invertible. So we have an inverse. Okay, is invertible. Great. So now let us continue solving this matrix, I mean this system, sorry, the system, and therefore for that we are going to use row elementary operations to do the reduced echelon form, okay, the reduced echelon form. For that, okay, we are going to use the bottom one in the bottom row, okay, as our leading coefficient now, and what we want is to get rid of this one and this one, okay. So for this we're gonna do, okay, so we do R1 minus 3R3 for the top 3 because it's a plus 3, and then R2 plus 3R3 for the second row plus 3 times R3. So we get so we will find 0. We'll start with the bottom one, 1. Okay. Now we have 0, 1, 0. Okay. And for the top, it's going to be 1 plus 0, 0, 2 plus 0, 0, and then 3 minus 3, 0. And what do we have on the other side? We have 5 because we didn't touch it, minus 2b2 minus b3. And now we have, we said R2 plus 3R3. So it's going to be, so remember, it was b2 minus 2b1, b2 minus 2b1, and then plus 3 times the bottom part, which is 15b1, 6b2, 3b3. Okay, and in the top, we're going to have the top one that we had before, okay, which is b1. So we have b1, here we are, and we do minus 3, the bottom part, which is minus 15b1 plus 6b2 plus 3b3. Okay, so if I put, or let's do some algebra here to make it nicer. 1, 2, 0, 0, 1, 0, 0, 0, 1, and at the bottom we have 5b1 minus 2b2 minus b3. Here we have in the second 13 b1 minus 5b2 minus 3b3, and on the top we have minus 14b1 plus 6b2 plus 3b3. Okay, great. So now we are going to use this one as our leading coefficient, and what we want is to get rid of this number 2, and for that we are going to take R1 minus 2R2. So we will get 0, 0, 1, 0, 1, 0. I didn't touch the second row, and then top one will be 1 minus 0, 0, 1, sorry. 2 minus 2, 0, and 0 minus 0, 0. So what do we have? We have 5b1, 2b2, b3, 13b1 minus 5b2 minus 3b3, and then on the top is going to be minus 14b1 plus 6b2 plus 3b3. That's the original one from R1, minus 2R2 minus 26b1 minus plus 10b2 plus 6b3. Okay, so we do the algebra and we will find 0, 0, 1, 0, 1, 0, 0, 0, I'm sorry, 1, 0, 0, 5b1, 2b2, b3, 13b1, 5b2, 3b3, minus 14 minus 26 minus 40 b1, 6b2 plus 10b2 plus 16b2, 3b3 and plus 6b3, 9b3. Okay, so the solution is x1, x2, x3 given by minus 40 b1 plus 16 b2, 9 b3, 13 b1, 5 b2 minus 3 b3, 5 b1, 2 b2 minus b3. Regardless of what the values of b1, b2, b3, we knew that's because the coefficient matrix is invertible, and this is the same as using the product of the matrices as the matrix minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1 times b1, b2, b3. Okay, and we know that x2, x3, if we use the matrix representation of the system, we know that we have the coefficient matrix A that we gave before, time x1, x2, x3 equal b1, b2, b3. That's the matrix representation of the system. And the solution, if A inverse exists, okay, we know from the theory, then x1, x2, x3 is equal to A inverse time b1, b2, b3, which tells me that A inverse, okay, is minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1. Okay, now we can easily check our answer by looking at what is A times A inverse, and we should find the identity matrix. Okay, if that's the case, then our calculations is correct. If not the case, then our calculation is wrong.